Welcome back. This is the second lesson recording for IM1, August 28th. So we've just finished the magic numbers exercise where you were undoing operations to figure out what the unknown number was. Okay, so let's connect that with algebra. Why did we do that? Well, we basically picked the number, doubled it, and added 5 to the result. And then we used the undo operation, and we did it in the reverse order. We started off with what was done last, which was add 5. How can we undo add 5? We subtracted 5, and then we, instead of doubling it, we divided by 2. Okay, so we can use the idea of undo operations to solve variable. Say if you have negative 5x plus 10 is equal to 20. How can we solve that? Well, you need to first analyze what operations we are applying to x. What's being done to x? X is being multiplied by negative 5 and then being added by 10. Okay, which is being done first? Is adding 10 first or multiplying by negative 5 first? Well, if you use the order of operation, you will know that we multiply first before adding and subtracting. So we need to start by analyzing what operations we are applying to x, and then we apply the undo operations to solve. So in this case, we multiply by x by negative 5. That was what was done first, and then followed by, then we added 10 to the result. Okay, so to undo, to find what the variable x value is, we need to start with what was done last, which is add 10. So we need to undo adding 10, and so we subtract 10 instead, and then we, instead of multiplying by x by negative 5, you are going to divide by negative 5. So let's show algebraically. Subtract 10. Whatever you do to one side of the equation, you need to do to the other side of the equal sign. So we're subtracting 10 from both sides, and that leaves me with this positive 10 minus 10 just becomes 0. So you're left with negative 5x, that just comes down from there, plus 0. And on the right side of the equal sign is 20 minus 10, which is just 10. Okay? And you know that negative 5x, anything plus 0 is just anything, right? So this plus 0, we can just get rid of it because it's not doing anything to it. So we can just rewrite this as negative 5x is equal to 10. And so what is happening to x here? X is being multiplied by negative 5. So then we undo, we divide by negative 5, just like what we said we need to do. After you subtract 10, you need to divide by negative 5. So we divide both sides by negative 5. Again, whatever you do to one side of the equal sign, you need to do exactly the same thing to the other side of the equal sign. That's the golden rule of algebra. Okay, so then you're left with this negative 5 divided by negative 5. That just becomes giant 1. Okay, it just becomes 1. Negative 5 divided by negative 5. If you know anything divided by anything, the same number, then it's just 1. So that you're left with just 1 times x, which is same as just x. And 10 divided by negative 5 is negative 2. Why? Because 10 divided by 5 is 2. And positive divided by negative is negative. So x is negative 2. And that's our magic number that we were looking for. Or we just solved the equation. Okay, let's try again with another problem. Okay, if you have x plus 4 divided by 3 is equal to 5. Well, let's go through the same thing. We need to analyze what operations we apply to x first, and then we need to apply the undo operations. So what are we doing to x here? X is first being added by 4 here, x plus 4, and to that result, the result is being divided by 3. So to undo the operation, we need to undo the divide by 3 first, which is multiplied by 3. So we need to multiply both sides by 3. And then to that, you need to undo add 4, which is subtract 4. So algebraically, multiply by 3. Whatever I do to one side, I need to do it to the other side. So I am multiplying the left-hand side of the equal sign by 3, right-hand side by 3. Notice that when I'm multiplying anything, I need to multiply to the whole side. I can't just multiply to just part of it, like 3x. I need to multiply the whole thing. Okay, notice what happens. Here, 3 divided by 3. What's 3 divided by 3? That's just 1. So this 3 and this 3 cancels out to be 1. And you're left with x plus 4 on the left-hand side. And on the right-hand side of the equal sign, 5 times 3. 5 times 3 is just 15. So you're just left with x plus 4 is equal to 15. And then from here, you know that x is being added by 4. So to undo add by 4, you're going to subtract 4 and subtract 4 from both sides. And you're left with x plus 0 is equal to negative 11. Because 4 minus 4 is just 0. And which is basically same as saying x is equal to negative 11. Okay, great. So hopefully you're starting to get what we need to do when you see an equation like this. So we're going to do some class practice problems. So there are 10 problems. So at this point, I need you to pause the video and copy these questions down. Okay, copy all 6 problems down. Leave some space in between so that you can solve the problems and so that you can find the value of the variable. And there are 4 more problems here as well. Okay, so there are 10 problems that you should be working on right now. Okay, and I am actually going to go through each one of them slowly in this recording. If you feel that you can do this, you should certainly go ahead and do it on your own. If you feel that you need a little bit of help, please continue to watch the video. Here we go. So we are going to I am going to walk you through solving each one of the problems. Now look at the first problem. We are going to use the same method. Okay, so consider what is happening to n. What is being done to n right now? N is being added by 19. Okay, so to find n, we need to undo adding 19. How can we undo add by 19? We need to subtract 19 from both sides, like so. And then what happens when you do that? 19 minus 19, that just becomes 0. And you still have the n from down there, from that. And that comes down and you're left with n plus 0 is equal to, what's 29 minus 19? That's just 6. And we know that n plus 0 is just same thing as anything plus 0. When you're not adding anything to it, so it just becomes the anything. So you're just left with n is equal to 6. Okay, what about the next problem? X minus 14 is equal to negative 25. What is being done to x? X is being subtracted by 14. How can we undo subtract by 14? We are going to add 14. Remember, addition and subtraction, they undo each other. So that just becomes 0. So you become x plus 0 is equal to, what's negative 25 plus 14? We are adding 2 numbers with opposite signs. That means we need to find the difference. 25 minus 14 is just 11. And we are dealing with, okay, which is the bigger number, 25 or 14? 25. So in the sign that goes with it is minus. So it's going to be minus 11. And we know that x plus 0, well, plus 0 is just really not doing anything. It's the same as x is negative 11. And that's my final answer. Okay, I'm sorry, it's having a hard time focusing. Okay, hopefully, there you go. All right, so then let's look at the next problem. What is happening to x here? Okay, what is happening to x? X is being multiplied by 4. X is being multiplied by 4. So how can we undo multiply by 4? You are going to divide both sides by 4. And I am going to represent divide by 4 with this fraction line, because fraction line basically means division. Okay. All right, so then 4 divided by 4. Look what happens. 4 divided by 4 is just my giant 1. That's my giant 1, or 1. 4 divided by 4 is just 1. So that goes away, and you're left with just that x here is equal to, what's 12 divided by 4? That's 3. Negative divided by positive is going to be negative. Okay, I don't know why it's having such a hard time focusing. Here we go. All right, let's go through this together. Okay, x is being divided by 9 here. So how can we undo divide by 9? I am going to multiply by 9. And this just becomes my giant 1 here, and that cancels out to 1. So you're left with x is equal to 8 times 9 is 72. Negative times positive is negative, so you're left with x is equal to negative 72. Let's keep working. Okay, number 5. What is happening here? N is the variable. It's first being multiplied by 3, and the result is being added by 2. So to undo, we need to deal with what was done last. What was the very last thing that we did? Well, the first step was multiply. The second step was add by 2. So we need to undo this add by 2. How can I undo add by 2? I'm going to subtract 2 from both sides. And that just becomes 0. And you're left with 3n plus 0 is equal to 14 minus 2 is what? 14 minus 2 is 12. Now I like to keep my equal sign to follow. And then now 3n plus 0 is just 3n. So I can divide this by 3 because here n is being multiplied by 3. So from here, that just becomes my giant 1 again. And you're left with n is equal to 12 divided by 3 is 4. And that's my solution. Okay, let's do the next one. Okay, what is happening to x? X is being multiplied by negative 4 and then subtracted by 10. So the last thing that was done to x was subtract by 10. So I am going to undo subtract by 10 by adding 10 to both sides. That becomes 0 and you're left with negative 4x is equal to 6 plus 10 is 16. And then from here, I am going to divide both sides by negative 4. Why? Because negative 4 is being multiplied by x. How can we undo multiply by x? It's divide by 4. Or negative 4, I should say. Okay? And so that this just becomes my giant 1. And that goes away. And so you're left with x is 16 divided by negative 4. 16 divided by 4 is 4. Positive divided by negative is just going to be negative. So here is my answer. All right, I have to quickly finish up with my recording. So look at what's happening here, okay? Well, the variable's on the right-hand side. That's okay. That's no problem. You just need to think about what is being done to it. M is being subtracted by negative 2 first because of the order of operation inside the parentheses. And then to that is being multiplied by negative 7. So the last thing that was done to it was being multiplied by 7. Remember, there is an operation between a number and the parentheses. There is multiplication. So to undo multiply by 7, I am going to divide both sides by 7. And this just becomes my giant 1. And you're left with 84 divided by 7. That actually turns out to be 12 is equal to, and you're just left with m minus 2 here because this 7 and 7 cancels out to be 1. Then you are left with this. What do? I need to get rid of this negative 2. How do I do that? I am going to undo subtract by 2 by adding 2 to both sides. That just becomes 0. And you're left with m is 12 plus 2, which is 14. And then let's do number 8. I'm going to do it really quickly. I am going to subtract 8 from both sides first. Okay, and that just becomes 0 is equal to 8 minus 8 is just 0 here as well, is 7p. Okay, now you might be thinking, oh, what's wrong? It's 0. No, you just need to divide by 7 both sides again, and you're left with p is equal to what's 0 divided by 7? It's still 0. So p is also 0. Okay? Okay, so I'm going to run out of time. So I actually just quickly did the problems. And so that you can see my worked out solution. Again, you need to be thinking about what we need to do. I am going to start by multiplying both sides by 5 first. Why? Because the last thing that was done to x was divide by 5. So I multiply 5 by 5 both sides, and then you're left with negative 11 plus x is equal